Hi everyone, good afternoon. So today is welcome to my sessions. Actually, I just want to start with this slide first. Actually, people just, when you're getting old or you age, normally you get reverse in terms of happiness and wellness. Yes, of course, because when you're getting old, you have come with a lot of disease, you feel very slowly, you can't run very fast. This is just destroy all your happiness. So is that going to be better if you can just reverse it back? So you're getting old, you stay longer with loved ones, and also you can come with happiness and also good health. So this is why, is a topic for today. So actually I'm the representative of the AVS company, and today I would like to introduce about the topic of the innovative biomarkers indicating cell sensitivity. Cell sicknesses is the ways that you're getting old. That's a simple terminology. And so we start with the first one. What is cellular senescence? So what is it and what cause of it? And why is it so important to know this biomarker? Why need to know this biomarker? You can see that there's a lot of factors in order to contribute the aging process. So it starts from DNA damage. I don't want to just go into more detail because Dr. Lee introduced very well this morning, and actually I don't want to just repeat it, but I just want to go very quick for the introductions of the aging process. So you can see that a lot of process that can contribute to your aging. So the next one, the question is going to be the cellular cell, why is aging and what is it? So actually the definition is a response of normal cells to potentially cancer causing events. So you can just you can see that start from a normal cell. You get some proliferations, you get some cell proliferations, but under some conditions, for example, damaged telomere, activated oncogenes or oxidative stress, that will change the proliferate cells to the senescent cells. And this process, actually they can go to two pathways. The first pathway, just go back, just go to the other pathway. The first pathway is just go to destroy all the P50, which is a protein to protect us from the cancer. And once this protein destroyed, what happens is just go to what we call damaged proliferating cells that lead to cancer. And also, in the other pathway, you go to aging process. So this is the ways that, why normal cells go to cancer and the aging cells. Okay? So the next one, what cause of this? So you can see that this is kind of, a main factor contributing to aging process. DNA damage, oncogene expression, and super mitogenic signal. So that means when your cell divide, you get when divide so fast, it's called super mitogenics. And every time, this morning Dr. Lee just well mentioned about telomere shortening. That might relate to the aging process. And that thing as well, when you get every time when you do mitosis, when you do cell replications, your cell dividings, what happens? You're shortening the telomere. And the telomere is just a portion or a fraction that just attached to the chromosomes. Every time when cell dividing, we're shortening telomere. But luckily, if you shorten telomere every year, we should die, at age about 30. But why we can't live for 80? Why some people live for 100 years? Because inside our body has an enzyme called telomerase. And telomerase just, when you do shortening from the cell dividing, the telomerase do the opposite direction. They just try to extend your telomere. That's why they balance between shortening and extending, so that's why you live longer. So, the next one, this is a process of the cell aging. So cell from old donors divide less often than cell from young donors. And cells from child-like species are more sensitive to senescence inducing particular oxidative stress than cells from long species. So all the factors, I don't want to just read all of these, but you can just read on the board here. But actually, these call all the factors that lead to the aging process and then lead to this ugly phase that we will, at the end of the day, we will have like this. But after listening to the lecture today, you can slow down this ugly phase. So, this is what is the morphology of aging cells. So you can see this is the characteristics of the aged cells. For example, you produce a lot of beta-galactosidase activities. Actually, this kind of enzyme is a good biomarker for aging cells. Because in a normal cell, you have the beta-galactosidase, but at pH about 4. But when you detect these galactosidase, sorry, I'm not very familiar with these things. When you have a lot of beta-galactosidase level at pH about 6, you can detect it. That indicates your cell age. So you have increased size of nucleus and nucleoli, and also increase the number of multinucleate cells, and increase the number of lysosomes, Golgi, and cytoplasmic microfilaments. So this is what the cell look like when you're getting old. So if you look on this fibroblast cell is just like your skin cell. You can see that when you very young, it look very smooth, like a very good shape of your fibroblast cell. But when you're getting old, it forms a filament. So you can see a connective issue and some is damaged. So this is an aged cell. Okay, so we need to know the hallmark of aging. Actually, there's 4 factors contributing to the hallmarks of aging. So the first one is genomic instabilities, telomere attritions, epigenetics alteration. Epigenetics alteration is just like some alterations or some change from the environmental, something that we cannot control it. And also the loss of protein functions is called loss of proteostasis. And these kind of what we call primary factors in order to contribute for the aging. And then we have another 3, which is a consequence of the primary factors, which is deregulating nutrient sensing, mitochondrial dysfunctions, and cellular senescence. And also, all of these is contribute to the stem cell exhaustions and also intracellular communications. So this is a hallmark of the aging process. But this one is very good. When you know the hallmark of aging, you can lead to the way to treat or to fight with the aging process. And this is why, you can't just like do, for example, what Dr. Kampun doing now, just like in a stem cell-based therapy. You can have a lot of therapy, natural-based, in order to fight, according to the hallmark of aging. Because the factor contribute to aging. So you know the way how to fight with the aging using our science and innovations. Okay, so now, one of the biomarker for aging is telomere and telomerase. Okay, so you can just like measure this one. But normally I just like very quick for this telomere because Dr. Lee just mentioned this morning. But what happened inside your body? Okay, we have like a marker on top of that telomere called P53. And P53 is very important. Actually, P53 is a guardian protein, is a protecting protein. When we have this P53, it will prevent from any destroy from DNA or whatever. But for cancer cells, you lose these proteins. When you lose these proteins, it goes to the process that cell division continue without telomere, leading to chromosomal realignment. So that means you just like get destroyed. You don't have like a signal for the cell to go apoptosis. So that's why it's just like grow forever and limitations. And actually, if you look on the age and telomere, so if some of you here in the meeting room go to see measuring telomere, compared to me, some of you might just like get telomere shorter than me because due to the age. So that's why telomere length actually is proportional to the age of that people. And actually, when you do the gel electrophoresis, you can see that, telomere for the aged people, 71 years old, you just normally you get very, very short length of telomere. And also, luckily, everyone got telomere. But why telomere, as Dr. Lee mentioned this morning, is not very conclusive biomarker for aging process. I'll tell you later. But some animals, including human beings, we got some length of the telomere. And every year we lose the telomere, according to species of the animals. For example, human being, we lost about 70 base pair a year. If you compare elephants, it's about 110 base pair a year. So the rate is very important because, if you can, you design some drugs, you design some medicine in order to extend the telomere. So you can calculate it back. For example, if you can stop the base pair shortening, you can calculate back to the aging that you can stop. For example, I got some medicines, I got some Thai herbs that can just freeze your age for 7 years. So how can we know that we can stop your age for 7 years? Because we calculate for the base pair that we can protect for the shortening for each year. And this is the telomere loss rate. It depends on a lot of factors. Actually, oxidative stress, you have the information that Dr. Lee mentioned this morning, and all of these factors lead to the telomere erosions. You can get a shortening of the telomere. So this is why Dr. Lee just mentioned this morning, telomere biomarker is not very conclusive because this species, this one, this is a fungi, they don't have the telomere. And also some people who got this kind of disease, Hutchinson-Gilford, they don't have the telomere related to the aging process. So that's why it's not very, very conclusive. We just want to use telomere as a biomarker for the aging. Okay, the other one for biomarker for aging is called associated beta-galactosidase. As I mentioned to you before, for a normal cell, HPH about 4, you have this kind of enzyme. It's a very, very good enzyme inside your mitochondria. But when you're getting old, this enzyme is increased at pH about 6. So that's why you can use this enzyme in order to monitor your aging process. So this one is a acceptable biomarker for aging process. And actually the detection of this enzyme is very easy. You put some compound called GAL. Normally, the classical one, they put X-GAL into the cell. You incubate it. And the enzyme, we have a lot of enzyme of this one, it will hydrolyze X-GAL to get a fluorescence compound. So you can detect, you can see under microscope that the cell is fluorescent. So you can, if you have a lot of a strong fluorescence, that means you have a high quantities of the beta-galactosidase, that means you age. Why we need to do this one? Because actually we don't want to see your face when we want to see the aging process, because some people maybe we look at Dr. Kampon. He look very old from his face, but actually inside, he may just 30, I don't know, he might just guess some age. So that's why biomarker is very important. We don't want to see the face because, you have an experience. Then you have some friend who just got no hair with the same age as you. That's why, people or scientists, they not count on the physical appearance. What they count for the biochemical factor, biochemical biomarkers in order to tell your age. The other one is called certain genes. And actually certain gene is a guardian. So this one is not magazines or newspaper, but actually is a guardian of our body. Because every minute we get destroyed, our cells, our telomere destroyed by our cell. Because we have an auto-apoptosis in order to just eliminate the bad cells out of the body. But actually all the auto-apoptosis, it just eliminate the healthy cell as well. So the sirtuin is a sirtuin gene. It produces a protein called sirtuin that will protect us from the destroy from DNA. So that's why, sirtuin is under the research to be acceptable for the biomarker of aging. So that's why this one is a very potential biomarker in the future for the aging process. And actually, our laboratory, our company can just do some assay of all of the biomarkers. As I say, when you want to measure your aging process, you're not just choose only one. You're not going to choose only telomere. Because telomere, and we just talk to medical doctors, some say yes, some say no. It's a pro and cons. So we need to measure other biomarker as well, indicating whether you're going to age or not. And okay, I just want to switch a little bit after introduction about cell aging. I want to introduce about MBS. Okay, this is the way to sell. Okay, it's not for selling. Okay, MBS company actually I'm very proud because we joined venture with NASA, Ministry of Science. So we have a NASA to back up us. And what we do, we located at Thailand Sci Park. We located in one building. This is a building next to this building. So if you finish very soon, you might just want to look at our laboratory and our office as well. And also, we just locate ourselves, as I mentioned this morning, that in Nanjing. Okay, so the director of ASEAN, CIC or China Europe Innovation Center is Cindy. So she's just lead me to step into China land. So we have the office over there. And also in March next year, we will have the office in Tokyo. So next March, we're going to go to Tokyo in order to see our office in Korea. And also we have a factory in order to just do some video extraction, we do some purification as well, and that's why NASA joined venture with us. Because right now it's just want to do extraction, you can do any factory in Thailand. But if you want to make herb to medicine, you need one further step called purification. So for example, when you do extract the herb, you get 100 of compounds. But just only one compound that can just exhibit pharmacological effects. So you need a purification step. And that's why NASA want to invest, because NASA and Ministry of Science and Technology, they need to invest some things that will advance the country. That must be the technology leaving the country. So that's why they want to do the purification step. And also, if you want to make microcapsules, what we call a micro and nano encapsulations, we have the facilities in order to operate, to make the molecules. We have a very, very big project with two companies. One is a Jietai, it's a very, very, very big agriculture company, and the other one is a Lion. So we have the micro encapsulation projects. So now, what is related to what I taught recently is what we call soluble matrix, soluble mix center. So you actually, you might familiar with, when you want to fasting, don't drink, don't eat for 8 hours just to see the doctor in the morning. So why? You need to just let the doctor or nurse sample your blood for analysis. But it's going to be better if we don't want to sacrifice our blood. What we use is saliva. Because actually, your saliva is the mirror of your cell. Every metabolized proteins, nutrients present in your blood, it will also present in your saliva. But it got some limitations, of course. Otherwise, saliva is a very, very popular, and people are going to just switch from blood to saliva. What is the limitations? Because something that you want to analyze is present in your saliva as a minute amount. It's not a lot. And also, when you take the saliva, your protein, actually the enzymes in your saliva. For example, this is a good way. When you want to measure some proteins, And protein is a biomarker for some disease in your saliva. Your enzymatics, process will destroy that protein, will degrade that protein. So this is a limitation. That's why when you're sampling your saliva, in order to prevent the degradation of the proteins, you need to stabilize it. You need to stabilize the saliva. But there's a lot of good things, why you need to switch from blood to saliva. For example, of course, it's not very painful. Yeah? You don't have to use like a nurse. You can just sample your saliva at 7-Eleven. You can do yourself. You don't need a trained professional in order to just collect your sample. This is a good thing. So if you can just measure your biomarker in your saliva, it's going to be widespread. People are going to switch from blood to saliva because it's easy. You just spit into, I don't want to say spit that, but there's a lot of methods in order to just collect your saliva. You can spit, you can just swab your saliva and then just do some analysis. So there's a lot of good news about saliva detections. And actually, soluble concept, we try to measure all of these biomarkers that contributes to some related disease. So we use a technology called multiplex point-of-care testing in order to analyze your biomarkers, proteins, metabolites in your saliva, also in a microRNA in your saliva. But you might ask me, okay, I can analyze. You go back to your laboratory, you get back to your hometown, set up the laboratory, and then do some saliva test competing to me. Please. But because we have the patent for assaying the biomarker, this is a know-how. So people cannot replicate us because we have a know-how to just how to supply the saliva, how to do the assay of some biomarker. Because some biomarker, you need to develop your own assay in order to do the analysis. And also, this is our roadmap because Dr. Kampo just initiate the concept of biological immortality. So this year, we focus on the biological immortal program. But at the end of the day, as I say to you, right now, if you want to compare to the blood analysis, we can't compare because blood analysis is just like a god of analysis. They can analyze everything as long as the method and the technique available. You can detect all biomarkers. But some saliva, as I say to you, is a minute amount. We need to use a very, very sensitive instrumentation in order to get analysis. So that's why this is our roadmap. At the end of the day, we want to just replace the blood test with saliva test. And also, the biological immortal, of course, we can't avoid dying. We need to get, at the end of the day, stop breathing. That means bye-bye to this world. But actually, we want to stay longer in order to just stay with the loved one and also not just stay longer in the bed at hospital. But we just want to stay longer with happiness and wellness. So this is our aim. And also this is a kind of a service that provide. You come to us if you want to check for your saliva analysis. What you have to do, you just get the tube. We try to think about the channel that you can collect the sample, the collecting tube. Maybe 7-Eleven, is very simple. We just want to focus in Thailand first and then we move to China. But we use the same business model. So you collect from a convenience store, you just swab your saliva, put in the seal tube, send it back to our center, we get analysis. While you wait for the result, you download applications. And this application will be the way for us to communicate with you, to send all the results to you.
Cheek swab or saliva? Cheek swab.
Yeah, you can do both, but we have a lot of techniques, but we need to decide. The cheek swab is good, but you might just contaminate the blood. So you need to be careful about saliva. So when you get the result, we send to the application. So you can communicate with us privately. And also we just like to use a technique called blockchain in order to protect your privacy. And after that, Dr. Kampon will just like show on your screen, and then just like talk to you what kind of supplement and advise you what kind of behavioral change that you need to do in order to live up your health, and also just like decrease your biomarker indicating for aging. And then after that, we might just like provide what we call phytochemical and nutrigenomics programs. So this is the way, I think it's a game changing. Why? Because this is the way that you can sell your food supplement without the marketing cost. Because when you get direct to us, we don't need to add a marketing cost. We send you by the parcel. I got one of the customers in Australia. They talked to me that, okay, if I make a lot of food supplement, it's impossible, not impossible, but it's very difficult in order to export to Australia, because they got, like the Australian FDA, they got a lot of regulation in order to prevent you to import to the Australia. But it's quite different. When you send the parcel directly to Australia, you can't send the parcel. And I believe, this world, the logistics is very good. So you can just like, send to your customer without making cost very cheap. Okay, so I just like want to introduce the business in the company. We have what we call pharmacological compound discovery from natural products. So what we concentrate on, we just like concentrate on the active compound in natural products. And actually, if you search, Thailand is the #1 biodiversity. So we have a lot of herbs, we have a lot of fruits, trees that pose the pharmacological compounds. And actually, what we try to do, we just like want to make a story from the history. And actually, the reason why we merge with China, because we want to utilize the Chinese herb and also Thai herb, because both of these countries we have a long history for this book is a very very long and also China got a book kind of library of the Chinese herb that can treat a lot of disease as well. But now we need to just like merge together. At the beginning we thought that okay, we want to serve for two countries. The customer in Thailand and also the customer in China, because we, the only one, can access the library of both China and Thailand herbal database. And what I just like to mention why there's not interest to invest into our company, because we have extraction you can find any factory in Thailand or in Southeast Asia. But if you want to do one further step, purification, yes, you need to come to us. So I'm looking for collaboration with some of you might just like come from other countries that we can just like add flag, more flag in our collaborations. Next year we're going to add Japanese flag as well, because we're going to locate in Tokyo. And that's what we call a third generation of nutraceuticals. But now I would like to introduce a second generation nutraceuticals. And actually we just like very very privileged to collaborate with Kunyat-Chai. Kunyat-Chai just like bring the new innovation to us. It's called Cell Matrix. And Cell Matrix is just like a Nobel Prize award winnings. And what they do, the Cell Matrix concept is just like they need to use normally just one nutrition. You can't just like get into the cell. You need some code. Existing compound in order to help the other compound to get into the cells. And that's why it's improved the cell absorption. You can see the graph just like when they put Cell Matrix, you can just like increase the cell absorption. But our know-how, we discovered some herbs that can let the cell communicate each other, called cell synapse. So now your cell is happily communicate with the neighborhood cells. So that's why it's very important, and that's why we call enhanced cell communication. You can see that this is kind of a nerve cell. It's decreased when you just like put some compound to deregulate your nerve signals. But when you add our herd, you can see that the signal is recovering and just like in a significantly increase. So this is what we call a second generations. And that's why, we access all the database for Thai herds and also Chinese herd in order to make what we call a cell synapse technology based herd. And why we need to do that, not just like, for the sake of Thai people, for the sake of Chinese people, but we just like, want the world happy. Everyone in this world needs to be happy with the second generation nutraceuticals. And this kind of Thai herds, okay, this one of the database is very, very small. I do apologize, but we have a lot. We have, a lot of things. For example, some of the compound you can lower your blood pressure, your sugar is very, very competitive to the function of metformin. The metformin is like the drug for lowering your glucose level. This kind of database you can just like use. We select which one you want to take for the function. You just have to make a food supplement. For example, we have like about 6 samples. We use all Thai herd in order to just like get a stem cell enhancement. For the telomere elongations, we can extend the telomere with Thai herds and also some proteins for plant. We also just like want to do this one is very interesting and is undergoing research. So we do a phospho targeted. Normally, inside your body, you have the complex between phospho and P53 protein. It will just like bind together. But when some scientists in Netherlands, they discover some compound. It's called this compound is a phospho DRI in order to destabilize the complex here, and destabilizations lead to the cell apoptosis. That's why stop the cell senescence, stop the cancer cell. So you can see this is the mice from their experiments. After just injections of phospho-DRI, you can just like get a lot of hairs for the mice here. So this one is very good, but what we try to do, we just like want to do some screening of the natural compounds, the active from natural compounds in order to destabilize the complex here. Normally this phospho-DRI is just like a peptide. And also because, as I mentioned, I'm the scientist at NASA, I'm spin-off, so I can just like access the database of Ministry of Science and Technology. When you want to do some herbal screening to get the final active compound, you need to do this kind of process in order to get one pharmaceutical compound that active. And actually, at the end of the day, last year, I discovered some compounds from pepper in order to just like we have like a EGF, epidermal growth factors, like activity, and this kind of discovery we can just, I won 2 awards last year from NASA. And also, I just like to collaborate with VitalStem and VS Lab in order to make a molecular chaperone. And actually, because my thesis and my master degree in Australia, I doing something about a molecular chaperone. It's called alpha crystalline. And actually, you can see that inside your, have you ever, cataract, yes. So that's why when you look into their eyes, you get like a cloudy because of the protein precipitation. But what I worked with my professor when I did my master degree, we isolate the chaperone protein called alpha crystalline. And this alpha crystalline will just like, normally, when the protein precipitates because it's denatured. So the molecular chaperone, which is like hold it into like a big barrel. You let it fall back to the native state in order to just like get a proper functions. And actually, right now, my research, when I did my master degree, they make like they are in the clinical trials in order to just like get injection of alpha crystalline to the cataract, in order to dissolve the precipitate proteins to make your eyes lens very clear. And also we have a smart material, but I don't want to mention too much. We provide a service for microencapsulation as well. So we have a lot of projects with a Thai big company. And this is kind of, actually I feel this one is very hard. I'm not sure that we bring some sample or not, but we develop some menthol spray, a cooling spray. When we do the microencapsulation of the menthol, when you spray into your clothes, you can get like a feel very cold for more than 2 to 3 hours. We have like a durian anti-acne spray, but all of this is microencapsulation technology, and we have like, apply is the typers in order to just like relieve for the muscle pain. And also we have a big project with Jietai about the herbicide and pesticides microencapsulations. And then we have what we call a second generation of fortified food. So we make like a fruit enzyme caviar. Yep, and that's going to be all my presentation. Thank you very much.